There are cases where we would like to compare groups on more than one dependent variable. And we can do this by using a procedure called multivariate analysis of variance, or Manova. However, one of the assumptions or one of the issues that we need to consider when combining or comparing three dependent variables simultaneously, or I should say when using three dependent variables simultaneously to compare groups, is that we want to ensure that they're somewhat related. So for this example, we're going to compare the three levels of father's education on grades in high school, math achievement, and visualization simultaneously. And so to determine if these variables are somewhat related, we can correlate them. And so we're going to move grades in high school, math achievement, and visualization to the variables box, and then click OK. And we can see that grades in high school and math achievement are moderately correlated, as the visualization test in math achievement. The correlation between grades in high school and visualization is somewhat low, but nevertheless, for the purposes of this example, we're going to go ahead and do the Manova analysis. So to do the Manova analysis, we go to Analyze, General Linear Model, and this time we go to Multivariate. And notice we can put in more than one dependent variable because it says dependent variables. So I'm going to move grades in high school, math achievement, and visualization into the dependent variable box. And then I'm going to move father's education revised into the fixed factors box. Now, I do want a post hoc test because I want to be able to know on what dependent variables different levels of father's education differ. Go to continue. And then for options, I'm going to put display the means for father's education and overall, because that will give me the grand mean. And then I'm going to check descriptive statistics, estimates of effect size, observed power, and homogeneity tests. And then I'm going to go continue and then OK. So the first part of my analysis, my output, provides me with descriptive statistics for each of the dependent variables that we're comparing the three levels of father's education on. So you get the means and the standard deviations as well as the numbers in each group. The other important piece of information that I obtain is called the boxes test. Now think of the boxes test as a test of multivariate homogeneity. So we're looking to see if the covariance matrices or the variance covariance matrices are significantly different across groups and across the three dependent variables that we're analyzing. And in this case, the boxes test is not significant. And so this tells us that we've met that assumption. Now, the multivariate tests tell us if there's a significant difference among at least one group across those three dependent variables. And typically, we will look at Wilks lambda as our statistic of choice. Oh, I should be down here in the Father's Ed Revised. And so we can see that regardless of which of these multivariate statistics we look at, they're all significant. Wilks lambda is typically the one that's reported, although there's reasons to report these others. For example, if your box's test is significant, you might choose to report Pillai's trace. However, the literature suggests that all of these tests are robust with respect to violating this equality constraint of homogeneity of variances and covariances. We notice that our Levine's tests for each of these groups are not significant. Of course, this is right on the cusp, and I'm not going to worry about something that's so close to 0.05 in terms of suggesting that that's going to adversely affect the outcome. Now we have the test of between subjects. Basically, what these tests are like is that it tells us for each of the variables if those levels of father's education differ significantly from one another. So you can see for grades in high school, that is significant. So what that means is at least one group differs significantly in terms of average grades in high school. In terms of the math achievement test, that dependent variable is significant, and that suggests that at least one level of father's education or one group differs from another group on mean math achievement scores. However, for the visualization test, we see that this result is not significant, so there's no significant group differences when comparing levels of father's education on mean visualization test scores. We can go and move now to the post hoc tests. So the post hoc tests tell us where the differences are. It's just like interpreting the one-way ANOVA post hoc tests. So you can see for this test, grades in high school grad or less, and some college do not differ significantly on grades in high school. However, students whose fathers had a high school diploma or less compared to students who had whose fathers had a BS or more, high school students, or these students, scored significantly lower. And we can interpret the rest of the post hoc test in the same manner. These are the homogeneous subtests, post hoc tests. We typically don't look at those as much. So basically, these are the this is the way that you run the Manova test and how you interpret the results.